Hey, YouTubers, Tazman here, bringing you another episode of Taz Teaches Java. And in our last episode, we were working on our generic kind of card engine or card game engine, and we built our card class or object. Yeah, I guess it's class. We haven't built any objects yet. And I think we're pretty happy with it. So we're going to start working on the deck today. So this will generate an individual card and keep the values for that card for us. And I believe, yeah, we have get value, get suit weight, and our toString to get that. Now, was it? No. I was trying to remember. I was thinking I might want to just add a value and suit on those as well. Nah, let's not do that. Let's not mess with that for right now. So let's go ahead. We created all our different objects or our classes that we were going to need for our objects. And so now we're going to work on the deck. So if we think of a deck, we're going to want basically, if you think of a deck of cards, it's multiple cards. And the way we deal with multiple things in variables is we have an array. In this case, I think we want to use an array list. So I think we're going to do ARAY array list. And let it think. There we go. So it adds our array list up there. And our array list is going to hold cards and type card. And this first one will be cards. Now, the reason I say the first one is because I think we're going to actually have multiple array lists because we're going to want to keep track of cards that are in the deck, cards that are in play, and cards that have been discarded. That way, we would say, okay, well, if we want to reshuffle the discard back in, we're not going to generate new cards that are actually in play because that wouldn't be right. So we're going to say a new ARRR array list. There we go. Like that. And then like I was saying, whoops, that was the wrong thing. There we go. And we're going to want another one, array list. And once again, it will be type cards. So, or card, not type cards. And this one we will call, let's just call it in play. So these will be all the cards that are in play in everyone's hands. And then each person will have their own little array list of what is in their actual hand. But this is just a way to keep track of all the cards and where they currently are. So do new. Oh, that was bad. Control A on accident. New. Let's see. A array list. There we go. And then our last one, like I said, this will be our discarded pile. DA array list. Right there. Of type card. And we'll call this one discard, maybe. Discarded. That's even better. A new array list. Okay, so I think that will be what will hold our different array lists. So now when we're, let's see, we might want a couple extra. We might want one other is how many decks are we going to do? So let's do a private. And I always forget to do the private thing. We want this to be private. We want to force it. We want to force our other classes to access getters and setters for this. So we're going to have this one, and this will be number of decks. Or should I call it? Yeah, let's just call it decks. DECKS. So this will be the number of decks because in some games maybe you're using 2 decks, which is 52 cards per deck. And if you have 2 decks, then of course that's 104 cards. So you might want to keep track of that. So keeping that in mind, we want to give the option of saying, if I don't say how many decks, I want to have a default set, right? So what we'll say is we'll create a first constructor, public deck, and if nothing is passed to this constructor, then we're going to say this, we're going to do a constructor chain, and we're going to call our second constructor, but we're going to pass it the value 1, which means if I don't give a number of decks I want, it's going to default it to 1. So let's go ahead and do public public and deck and int decks, right? And then of course this will set our value of decks. This dot decks equals decks. So this, once again, for those that don't remember, this is going to set our class variable of decks to the local variable decks. Then what we're going to want to do when we get a new deck, we want to probably, because when we're generating these decks, it's going to be in some kind of order. Like I said last time, we can use like seven lines to generate a full deck of cards. That's 52 cards and stuff. However, in the array, they'll be in complete order. It'll be, ace 2, 3, 4, 5, 6, 7, 8, 9 of a certain suit, and then it'll be ace through so on and so forth. So we're going to want to first generate a deck, but I think I'm going to call a full shuffle. A full shuffle. Is that how you spell shuffle? I'm going to have a method called full shuffle. And full shuffle will actually call something that will generate the decks, right? Because we don't want people to call a generate deck automatically. So let's just work really quick on our generate deck. Why I have it in my mind. So this is going to be private and void, and we're going to call it generate, generate deck. So this will generate a deck. It doesn't need anything because it's going to be able to get everything it needs up here, and everything is going to pass. So in order to do this, now you could actually generate a full deck of cards with just 2 for loops, and then your little command in there, or your thing that actually saves the value. But we also have the possibility of having multiple decks, so that's going to add one more for loop in here. So we're going to start with for, and let's just call it int deck. So this will be our deck generator of how many decks we want. Man, my throat is all raspy and dry. And we'll start that count at 1. Now normally we do these at 0, but in this case we want it to be, if we say 1 deck, we want it only to run once. If we had a 0 here, it would actually run it twice and generate a 104 card, 2 decks at 104 cards total. So then we want deck is less than equal to decks, right, which is the value here. So the first time it's going to be less than equal to, so it'll only run once. Perfect. Because now if we did less than, it wouldn't run at all. Because we have equals to, it will also run if we have 1. And this is just for a little more clarity when we're looking at the code. if we did 0 and we didn't have the equals, it would work as expected, but it'd be a little harder to understand. And then we're going to increment our deg. DCK plus plus. So right there's our main loop to generate how many decks we want. Next, we want to do our loop that has our suits, because we want to first do our suit of diamonds, and then spades, and then clubs and hearts, or whatever order we want to do that in. So we want to do our suits first, and then we want to generate the 1 through 13 card for each suit. And then once it's done that 4 times for each suit, we'll have 52 cards. So let's go ahead and say 4, and we're going to do int, and we're going to just call this int SUIT. So int suit. And once again, this one, now if you remember in card, we're expecting a 0 through 3 for our values. So we're going to go ahead and say suit equals, and say 0, because that was our very first suit. And then we're going to say suit is, and this one we don't want the less than equals to 1. Is that how I want to do that? Let me just think for a second. No, I don't think that's quite right, because we want it to be less than 4, wouldn't it be? Yeah, 4, because there's 4 suits. SUIT suit plus plus, like that, and then we go ahead and do that. So this is going to generate our suits, and now we just need to do the 13 cards. And in our cards, we're generating aces 1, and we're going all the way up to, ooh, this is kind of wrong. There we go. And then 11, 12, and 13. So we're not starting at 0 once again, so we want to start with 1, which means, just for making it more logical, we're going to do less than equals to. So we're going to say 4, and this will be card, whoops, for int card equals 1, and we're going to say card is less than equal to 13, because that's our high number. And then we want to say card plus plus, card plus plus. So there we go, that generates all those. Now I think we might want to have this guy be public. 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 I'm thinking. Yeah. Or not this guy. Public. Let me just think for a second. Because then we do the value. Actually, no, we might not need that public, because we're generating a card P. Or private. We might have to test this, so without 1 P only. The reason I'm thinking that is because, do we want to save? Well, no, we're creating a card, so this should be okay. Yeah, this should be good. So let's see. There's our last loop. This is going to get us our individual cards. Now what we want to do is assign a card to our array list. Now, like I was saying, an advantage of array list over an array is that they're dynamic. You can actually add and remove elements from it, and it changes the size of the actual array list. Where with an array, if I say I want a 13 or a 52 value, or element array, and then I only populate it with, say, half that, 26, that array is still 52 elements long. I've only populated with 26, which means those remaining 26 have 0 value or whatever the default value is in them. So it makes it a little harder to say, like if I'm doing a card and I say, okay, I do this card, with an array list, I can actually say, remove that card from the array list and put it in another array list. And so I can actually move elements from one array list to another, so to speak. What I'm actually doing instead of moving is I'm looking at what it is, I'm creating that same value in a second array list, and then I'm deleting it from the first array list. All right, so there we go. This will do that. So we need to say cards, C-A-R-D-S. So we're going to say cards.add, because that's how you add a new element to the array list. And we need to add a card. So we're going to say a new card. And if we go look at our thing in here, we can see when we pass it, all it cares about getting is the value weight and the suit weight. And then we're generating the value and the suit from these guys. So, oh, yeah, that's right. Value is blank because we don't, yeah, okay. So that will automatically assign those to it. So all we have to do here is pass it a value for our suit and a value for our card, and everything else will be generated for us. So let's just go make sure we get the right order. So we're doing, in our constructor, we're doing the value weight first and then suit weight. So we want to make sure we pass it in that order. We want to send the card, which is the, so we want to send card, and we want to send suit. So that will generate us a full deck of cards, but like I said, it's going to be in order. So what we're actually going to do up here with our full shuffle is the full shuffle is going to generate the card. But what we need to do is make sure that our array is empty prior to doing that. So what we want to do is make sure all our arrays are clear, because when we're doing a full shuffle, no cards will be in play and no cards will be discarded. But instead of actually figuring out which cards are missing, I think it's going to be easier to simply say, let's just erase everything in the cards and regenerate a new one. Then at the very end, we'll actually shuffle those cards once they're all generated. So that's what our goal here is going to be. So let's go ahead and do that. So we want to say PBL public void. Now I'm making this one be public because I want to be able to call outside of this class. I want to be able to do a force a full shuffle, not just only when our constructor calls it. So we're going to do public void because we don't need to return anything. We're going to do FULL SHU FF, oops, FFEL, right? Or is it LE? I think it's LE. Shuffle. I don't know. I'm terrible at spelling. I lived in Chile for 2 years, and learning Spanish and speaking it there for 2 years totally messed up my English. Okay, so what we're going to do, in order to clear an array list to set it back to its 0 value, all we have to do is say cards dot clear, and there you go. We're going to do that same thing with in play. We'll do it like that, in play dot clear, and then finally with our discard, we're going to do discard dot clear, discarded, and dot clear. So this is going to empty out all those arrays, making sure there's absolutely no values in any of them. And then what we want to do is call our generate deck. Generate deck. And finally, we want to shuffle the cards. Now, in order to shuffle the cards, in order to shuffle an array list, we use another class, a built-in Java class called collections. And if we do that, we should see it's in Java Utilities, and you'll see now it's added up top. So now all we have to do is go here, and it has a built-in method called shuffle. So you can see we can shuffle a list. So if we do this, we don't want it to be random, we just want that. And we want to shuffle cards. So there we go. So now when we generate a deck of cards, and we need a semicolon up there, when we generate a deck of cards, we will, well, when we generate a deck, or when we create a deck object, we are going to automatically create the shuffle, which is going to generate the deck and then shuffle it all up. So I think that's good. Now we're going to have two other types of shuffles we're going to want. I think maybe just one. I might have to think about it. All right, so there is our full shuffle. Let's see, do we want, we can test this if we display the deck. Maybe let's do that just so we can test and make sure we're actually getting a deck of cards that's proper. So let's go ahead, we'll create one more. This is going to go a little bit long, but I think we're going to end it with the display deck here. And we'll just do it to assist out instead of returning anything. This is more for testing, I think, or maybe later on you might want to display the deck. I don't know. We'll keep it in there just in case. But let's go ahead and create, let's do publi public, and it's going to be void because we're just going to output it to the screen. We just want to make sure this is working right, mostly right now. So display and deck, right? So we don't need to pass anything into it. And basically all we're going to do is we're going to use an enhanced for. And yeah, I think, yeah, we'll use an enhanced for this. But let's kind of give it a little statistics thing right here. S-O-U-T. Oh, one out. Oh my heavens. I want to type out. So we're going to do this and maybe say something like deck has, and then say plus. And we learned that we can actually get the size of an array by doing cards. Just trying to think. Yeah, I think this is what we want. So we want to say cards, and then we want to use its built-in function of size, and that will tell us that, and then we can say plus and quote and cards, like so. Then what we're going to do is use our enhanced for to actually output all the cards that are in the deck. So we say for, and let's see. So this is going to be a type of card, and we're going to call it card. I think so. And we are going to loop through our cards array, or our cards array list, and then we're going to do s out, and we just want to do a card. I think we're going to want one more function, so we're going to do s out card dot toString, but we want to do our own custom toString, so we're going to do that right down here. We're going to do our at override, at override, And we're going to go ahead and do our custom. Now let me just think how I want to do that. Actually, no, because we're doing card to string. We already built that one. We don't have a deck to string. So this will actually call our guy in here and say value of suit. Yeah, I think that's going to work perfect. Cards size. Why you know like that? Oh, whoops. The plus is on the wrong side of the quotes. There we go. Okay, so now let's go ahead and I said we're going to probably create a war game, right? So we're just going to go ahead and call this war. War. What is it good for? Okay, so this is going to be where we're going to do our thing. So we're going to do our main, right? And we need to create a deck. I don't think we need to create an actual card, just a deck. So let's go ahead and do deck, because it's going to create the cards for us. We're going to say deck and maybe call it deck. Sure, why not? Equals new deck. And the parentheses. We're not going to pass it a value, so remember our default constructor is going to say, oh, I'm going to pass a 1 to our change constructor. And then all we have to do is do d dot or deck de deck dot and display deck, right? That should do everything. We get rid of all our errors. Okay, let's check this out. And there you go. So right now it's kind of hard to tell. Oh, we're getting some errors. We have some errors. And it seems like, so what were our errors? It was, we expected always to pass this value. So let's go check real quick our 4s. Oh, this needs to be a 3. Remember, because no, that should be a 4. We're starting with 0. Where is our error at? Let's make this a little more valuable to us and say value error. So we know it's a value error, and here would be a suit error. There we go. Do that. So this needs to be 4. In other words, it'd be equals that minus less than equal to. Okay, so let's go ahead and run it. Oh, the other thing I wanted to do before we run it, well, I hit save, I didn't hit run. Let's not tell it to actually shuffle the deck. Let's comment this out so we can actually see the order, and we'll be able to see which one is actually failing us. So this is going to give us the warning because of that. That's okay. So let's see. We have anytime it is doing a 1, an 11, or a 12. Wait, 11, 12, or 13. So it seems like, but the other part is actually working right. So it actually is in our value here. So we're dealing from 1 to 13. And then when this is being called here, we're passing to the suit weight, the value weight, right? Or not suit weight, I meant the other. So value weight is greater than 1. So that's 2 through 10 should get a blank value. And those are working. So if we go look at this, we do get the 2 through 10. But when we're passing our set value is where we're getting our error. So let's do this real quick and just say, let's do it right here as a test. Let's say value passed or something. S out value passed. And then we'll say suit weight, or wait. Oh, okay. This is value weight. Value weight. We don't need this guy, I don't think. There we go. That's what happens when you copy and paste. You miss something sometimes. All right, so let's run that and see. There we go. Now we've got our ace. We've got our queen and king and jack. And they're all in order. So there are 52 cards. We got the ace of hearts through the jack, the king of hearts, the ace of spades. So that looks good. Now let's just do one other check real quick. Let's say we pass a 2. So if we're predicting this right, it's going to say we have 104 cards. Errors exist. What errors exist? Display. Oh, whoops. That was the wrong one. We want to put the 2 here. Okay. Run that. And now if we go all the way up, it'll be a little ways. We have 104 cards, so that's working perfectly. Now the other thing we're going to want to work with this this method, or this class, is we're going to want it to deal out cards. We're going to want it to, let's see, so we're going to want to be able to deal cards. We're going to want to discard cards. We're going to want to discard the hand. So a player has a hand. We're going to want to be able to discard their hand and put it into the discard. So I think those are things we're going to want. For troubleshooting, we might want to also generate 2 more of these at least that will at least tell us what's in the discard and what's in the in play. So if we ever want to display that information, like let's say for example someone is given the option, they're playing a game where they can go through the discard pile, find a card and put it in their deck. You know, there are various games like that, not necessarily card games, but let's say they want to do something like that. This would allow them to do that. So now you can see the thing we're going to do with dealing cards is once this is shuffled, we'll just simply remove one from the end every time. And this will make it so that we don't have to if we say dealt from the top, then we'd actually have to use processing to move all the elements, because this is element 0. This is element 51. If we remove it, then it just simply says, okay, here. If we did this, removing here, this would have to become the new 0. This would have to become the new 1, and so on and so forth. So it's a little better to actually remove them from the top of the deck and work your way down, or the bottom of the deck, or however you want to look at it. All right, well, I think that pretty much covers us for the start of this. We haven't finished our deck, but we have it doing some pretty cool stuff. We're able to see or generate an entire deck of cards, and if we simply wanted to generate a new deck, we could do this and say S out real quick and say \n to give us a couple of lines. Then we could say deck dot, and because we set the full shuffle to be available, we could actually reshuffle our deck and then do deck dot display deck, and we're good to go. So here you'll be able to see really quick that let's just look at our last card. 5 of diamonds, 10 of diamonds. Then we come here, it's king of spades, 5 of clubs. So as you can see, we're generating a whole new deck, 52 cards again. So works perfectly so far for what we want it to do so far. All right, my throat is shot, so I'm going to go ahead and call it. Thank you so much for watching. I really do hope you enjoyed it. If you did, be sure to leave a thumbs up down below. Aside from that, comment, like, and subscribe. Follow me on Twitter. Check out my Discord and my other channels. And speaking of other channels, on my Tasman proper channel, until I hit 1,000 subs, I'm having a great big giveaway when I hit 1,000 subs, actually. I'm going to do a Steam game giveaway. I'm giving away 56 games when I hit 1,000 subs on that channel. Right now, I'm almost halfway there, but with your guys' help, if you tell everyone you know about my channel, friends, family, neighbor, everyone you know, if they check it out and they like it, they want to sub to it, we'll be one step closer to that great big giveaway. So that's it. Until next time, I'll be seeing you later. Bye.